Alright guys, we're back again, and we're working on 6.1, which is domain and range, and this is part 1 of 2 videos we have for domain and range. Our objectives for this are to use set builder and interval notation, so we've got this kind of notation and interval notation as well, to write sets. Part B is to determine domain and range for any function, and it's really going to help you if you just go ahead and take the time to copy down with example 1 and 2 now, so pause it, copy these down as well as our objectives. And then as well as copy down examples 3 and 4. And just make sure that you're careful with where you start. For example 3, it starts at -4, +4, and it goes to, in a straight line, to 5, 1. And again, -4, +4 is a closed circle, and 5, 1 is an open circle. You might have seen these before in one of our previous units. In example 4, it's very similar, and it needs to go from -3, 5 all the way, across to 6, -1. Alright, now that you have those copied down, let's hoop this back up here. And again, if you didn't get them copied down, rewind the video, pause it, go back and copy everything first. So we're looking at domain and range. We've dealt with this before, so let's actually look over here. When we say input and output, we've done input and output. As a matter of fact, we did input and output in our last unit when we were trying to graph our families of functions. So our input is just our x value. So we have a bunch of x's over here. All of them, we'll talk about those in a second. Our outputs, our domains, are y values. When we say domain, we're literally just talking about the x values. And then when we say range, we're talking about the y values. And if you'll notice, we have two kind of just different functions down here. So example 1 and 2 are what's called discrete. They do not continue, whereas example 3 and 4, you can keep your line going across, and it just gets going. Here's everything in the middle's going. And then over here, example 4, there's everything in the middle touching as well. But these up here, for example 1 and 2, they're discrete functions. And all discrete means is that we're just going to write individual points. So I've got two different color highlighters. I'm just going to draw the points and connect them to their axis. Remember that our x-axis is our domain axis, and our y-axis is our range axis. So I'm going to take all these points and connect them to the closest point that they have on their domain and range axis. And it should tell you what it is. I mean, the first part, 4 should connect right to the 4 on the x-axis. The 2 should connect right to the 2 on the x-axis. 0 is going to connect to a 0, which is kind of weird that we go down the y-axis, whatever. -1 is -1, we've got -2, and we have -3 as well. So these are the points in which it intersects the axis. So then, if we're to write our domain, we can say our domain is, so this is a capital D and then a colon, and then to practice a fancy bracket, and I know it might take a couple times, but you'll get it. Our domain is, and we write this from least to greatest without repeats. So when we look at our domain, we're looking at our lowest number first, which is -3, put a comma, -2, put a comma, -1, put a comma for 0, put a comma, 2 is our next one, comma, and 4 is our last one. And then we finish it with this other end of the fancy bracket thing. So this is written in what's called set builder notation. We've got, it tells us our domain versus our range. We've got a comma, or sorry, a colon, and then we've got this in brackets and least to greatest. We're going to do the same thing with the range right now. So we're going to go for range values, which says we're going to connect each of these points to their y values. So -2, -2. We've got 1 to 1. Oop, this one also comes over to 1. 2 to 2. 4 to 4. And 5 stays on 5. So I'll just put a little dot around that. So we'll do the same thing. We're going to write our range values just in a list from least to greatest. So range values go from, okay, so we've got -2s in our list. We've got 1 and 1. We don't need to repeat it. It's in our function. It doesn't matter if it happens twice, so we're just going to leave it alone. Let's see, we've got 2 with our next value up, so -2, 1, and then 2, and then we go up to 4, and we stop at 5. Okay, and that's the whole thing. I mean, this is set builder notation. Like we talked about up here in our objectives, is written in this format. and it works really well for discrete functions. Okay, example 2. Example 2 is what's called a mapping diagram. You may not have seen this before. All it says is we have our inputs for our domains, really we should call these, and our outputs for our ranges. 5 goes to 11, 10 goes to 12, 12 goes to 13, 15 goes to 14. The one thing you should notice about this is that mapping diagrams do not include any sort of pattern. So if 5 just goes to 11, there may not be any rhyme or reason, and maybe we can find a function that'll say, hey, multiply by 2 and add or subtract or whatever to get to that value over here for our input to our output. But a lot of times this is just, can you look at this and can you look at this and figure out the domain and range. So our domain and range, this is still discrete. We're still going to write domain. We're going to write from the smallest number to the largest number. So domain is, fancy bracket, 5, 10, 12, and 15. And that's all of them. Range is, and again, don't forget if there are repeats, you just don't need to write any repeats. Range is 11, 12, 13, and 14. It doesn't matter, I just noticed, parentheses, let's fix that. I just noticed there's a 12 in each of them. It doesn't matter if we repeat across domain and range. What's important is that we don't repeat on the inside of domain and the inside of the range. Okay? Alright, and again, these are in set builders. So let's talk about our discrete versus our continuous. So earlier, in example 1, I made a map. I use my yellow highlighter for my domain, which is my x values, and then I use an orange highlighter for my y values. So I'm going to do this again before I try to write this. So I'm going to start at my lowest x value, which is -4, and then there's a point here at -3.99, and then -3.998, and then so on and so forth until we get all the way down here to -3, and then we repeat again. And it looks like we're going to go all the way up until we get to 5, and that's going to be an open circle, which is kind of a big deal. We'll make sure that we know that's an open circle up there. So I'm going to fill in all of this stuff down here to show, probably should go all the way down to that line, to show that I have all of these x values, even including all these decimals, whereas the discrete one up above didn't include the decimals. It was just individual points. So I need to write a function that, or not function, a list of values that instead of saying individual, here's one, and then here's another, and then here's another, I need to write one that says it includes all of this stuff. So here's how we do that. We're going to still use the domain and the range, so D colon and R colon, and we're going to say our lowest value for our domain is -4, is less than or equal to, because it's smaller than all this stuff, this is where it ends, it's equal to because it has a closed circle, just like we did back when we were doing just individual line graphs with this stuff. Our domain values are covered by x, and it's going to go all the way up until, so -4 is less than all of these numbers, which are going to go all the way to 0, 1, 2, 3, 4, and all the way to 5. And the difference on this symbol is this guy is not have the line underneath it to it. It's not equal because of the open, it's a big open circle, because of the open circle. I'm very creative here. I was writing it and I was like, oh, that looks like an open circle. So I'm just going to say, if you have that open circle, then you do not have the equal sign. And that's all we got to do for our domain. And this is what's written in interval notation. So this is called interval because we have a bottom part of an interval, we have a top part of an interval. Okay, so let's look at the range in this guy. So the range, our lowest range value, is going to start at 1. And it's again where this open circle is. So maybe I should draw that open circle over here. That might help. Probably won't show up with yellow, but I'll try it anyways. Nope, doesn't show up at all. Okay. So we have an open circle, and then it goes up, and it keeps going 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 up, all the way, and that's okay if it switches sides. Now we're just going to drop in the other direction, and keep going all the way across, until we stop at 4. And it doesn't matter which side of the graph we're on. So if all of this was in quadrants 3 and 4 on the underside of this graph, that's fine. Alright, so our lowest value for our range is going to be at 1. It's an open circle, is less than y for our range value. So domain has x's, range has y's, is less than or equal to 4. So when we're looking at this, it's just important that we say, oh, here's our lowest, here's our highest. So we're always going to go lowest value all the way to the highest value, and then whatever variable you have. So either x or y, depending upon whether it's domain or range. So lowest value to the highest value, and then you've got to pay attention to your open circle versus closed circle stuff. Alright, example 4 is very similar to example 3. It's another continuous one. I'm just going to do, instead of coloring everything in, I'm just going to color in the lowest value to the highest value. It's my domain. I'm going to go straight down. Looks like at -3. It's an open circle. I can keep going, but I'm just going to use a line. Keep going, I'm going to use a line. Keep going. We're switching to the underside into quadrant 4. Not a big deal. So we would just sketch up, if we were sketching all this in like we did in example 3, all the way to 6, which is an open circle as well. Okay, let's do the same thing with my range color. So my range color is going to go from -1 is the lowest on the y value, and then we keep coming, keep coming, keep coming, keep coming over all these y values until we get the maximum value of, looks like 5 right there. So we're going to write our domain is from our lowest value to our highest value. So the lowest domain value that I have is going to be -3 is less than, because it's not a closed circle here, x, and then it keeps going all the way over until I can get to less than 6. And again, we have an open circle for this end, so we're not going to worry about closing that underside, so this is good. Alright, and our range, we're going to have from -1 all the way to 5. So -1 is less than y is less than 5. And don't forget, we call this notation, we call this interval notation. Okay, this should be enough to get you guys started. Our worksheet's asking for you to tell me the domains and ranges. I'm not even asking discrete versus continuous. It's just kind of interesting that you can notice the differences on them, at least right now. So go ahead and get your worksheet. Let's get practicing. Ask me any questions you need to. Alright guys, good luck.